Have you ever wondered why your stomach sometimes cries in acidity, or why soap bubbles? And what are the components of vinegar? Well, all these are acids and bases in our daily life. In this video, we will be seeing the CBSE Class 10th Science Chapter 2, Acids, Bases and Salts. Here we'll be seeing the chemical properties of acids and bases and how do salts work. We have studied in our younger classes that acids are generally sour and they turn the blue litmus red, and bases are bitter and they turn the red litmus blue. But let us learn what are the chemical properties of acids and bases. Starting with, how do acids and bases react with metals? Well, any acid or base with a metal gives rise to salt and hydrogen. If we place the zinc granules in hydrogen sulfate, we can see that zinc sulfate is formed, which is a salt, and hydrogen gas is evolved. Similarly, with sodium hydroxide and zinc granules will also give sodium zincate and hydrogen gas. This is how acids react with metals. Moving on to acids with metal carbonates and metal hydrogen carbonates. Bases do not react with these two, hence we do not observe their reactions. So acids with a metal carbonate or hydrogen carbonate give rise to salt, water and carbon dioxide. So if sodium carbonate is reacted with hydrochloric acid, it gives rise to a salt, which is sodium chloride, H2O, which is water, and carbon dioxide. Similarly, sodium hydrogen carbonate with hydrochloric acid also gives rise to sodium chloride, which is a salt, water and carbon dioxide. How do we test that this carbon dioxide has been released? We do a lime water test where calcium hydroxide, which is lime water, pass through the carbon dioxide, which causes the formation of a white precipitate, which is calcium carbonate and water. Moving on to the reactions of acid with a base, which is also called a neutralization reaction. So whenever acid and base react together, they give rise to salt and water. Sodium hydroxide and hydrochloric acid give rise to sodium chloride, which is a common salt, and water. This is generally a reaction which is used to treat acidity in the stomach, where an antacid which contains a base is given to neutralize the hydrochloric acid in stomach. Let us see how metal oxides react with acids. Bases do not react with metal oxide. So acid and a metal oxide gives rise to salt and water. So copper oxide with hydrochloric acid gives rise to copper chloride and water. Magnesium oxide with sulfuric acid gives rise to magnesium sulfate and water. What can we conclude from this? If an acid is reacting with something and giving rise to salt and water, the something is basic. So we can conclude that metal oxides are basic in nature as they give rise to salt and water when reacted with acid. Similarly, when a base reacts with non-metal oxides, it gives rise to salt and water. We just saw that lime water, which is a base, when reacted with a non-metal oxide, which is carbon dioxide, gives rise to calcium carbonate and water. Hence, we can conclude here that non-metallic oxides are acidic in nature. Moving on, let us see what do all acids or bases have in common, which is causing them to react similarly in all cases. To test this, we react the acid or base with water, and we note that acid and water gives rise to hydrogen or hydronium ions along with the other element, and a base with water generates a hydroxide ion, and these, when soluble in water, are called alkalis. Hydrochloric acid is reacted with water, which also causes an explosion. It gives rise to hydronium ion and chlorine ion. Similarly, sodium hydroxide with water gives rise to sodium ion and a hydroxide ion. Mixing an acid or a base with water results in the decrease in the concentration of ions, hydronium ion in acids or hydroxide ion in bases, per unit volume, and this process is called the dilution. Let us now see how we know how strong the acid or bases are. There is a pH scale where P stands for potence in German, meaning power, where we measure the strength of the acid or base. Here, pH scale is used for measuring the concentration of the hydrogen ions. So the more the hydrogen ions or hydronium ions, less is the pH, which makes it an acidic in nature. And Less the hydronium ions, more the pH, which makes them alkaline or basic in nature. And anything in between is called the neutral. So in our everyday life, most of the items we see, such as pure water, blood, are all neutral in nature. And anything further, such as hydrochloric acid, the acid in our stomach, are all strong acids, and the sodium hydroxide, drain cleaner, bleach are all the strong bases in our daily life. Moving on to the importance of pH in our everyday life. The human body works at a narrow range of pH between 7 to 7.8. Any change in this can cause serious trouble in the body. Similarly, if the pH of the rain is below 5.5, it is considered as acid rain and it can harm the aquatic life. The soil pH is tested using a universal indicator, as plants require specific pH for survival. Again, the HCl in our stomach is a strong acid with 1 pH, which helps in digestion, and antacids are used to neutralize any excess acid for this. If the pH in the mouth goes below 5.5, the tooth decay starts, corroding the tooth enamel, which is called the calcium hydroxypeptide. And when a bee stings, it releases acids that can cause burn and irritation, which can be neutralized by a mild baking soda. Nettle leaves have small stings that contain methanoic acid, which cause burning pain. This is how different acids and pHs are used in our everyday life. Let us learn more about salts. Salts are generally formed when an acid and base react together and there is an exchange of ions. We have already seen the neutralization reaction where the acid and base together gives rise to salt and water. The hydrogen ion in the acid and the hydroxide ion in the base combine together to form water, and the remaining elements together form the salt. pH of the salt. So when an acid and base are merged together, we get a salt. So if a strong acid and strong base are mixed, we get a neutral salt. Similarly, a weak acid and a weak base give rise to neutral salts. Strong acid and a weak base give rise to an acidic salt, and a weak acid and a strong base give rise to a basic salt. Chemicals from common salt. NaCl, which is extracted from seawater or rock salt, is the raw material for various other chemicals that we use in our daily life. There is a process called the Chlor Alkali process where electricity is passed through the aqueous solution of sodium chloride called brine, which decomposes it to form sodium hydroxide. Here, chloride is released at the anode and cathode releases the hydrogen gas, and sodium hydroxide is extracted from the other membrane. The equation would be sodium chloride with water gives rise to sodium hydroxide, chlorine, and water. From here, we use the end products of this reaction to make other salts that we see in daily life, starting with bleaching powder. Slaked lime, which is calcium hydroxide, is merged with chlorine from the previous reaction to give rise to calcium chloride or bleaching powder. The uses of bleaching powder are used for bleaching textiles, fabrics, washing clothes, in laundry, wood pulp in paper industry, and as an oxidizing agent in chemical industries. It is also used in purification of water to mix it and make the water germ-free. Baking soda. The sodium chloride from the reaction is mixed with water, carbon dioxide, and ammonium to give rise to ammonium chloride and sodium hydrogen carbonate. Sodium hydrogen carbonate is the chemical name of baking soda, and this, when reacted with any acid, gives rise to carbon dioxide, water, and sodium salt of the acid. This carbon dioxide is what causes the baking soda to cause the rise in the food items that we see. Uses of this is used in breads, cakes, etc. Also used as antacids as it is a mild base. It is also used in soda acid fire extinguishers. Moving on, we have washing soda where the sodium hydrogen carbonate is heated to give rise to sodium carbonate, carbon dioxide, and water. And when this sodium carbonate is mixed with water, we get sodium carbonate and 10H2O. This is washing soda, which is used in glass, soap, and paper industries. It is also used in the manufacturing of borax. It is a cleaning agent for domestic purposes. It can be used removing of permanent hardness of water. Now, what is this .10H2O in sodium carbonate? So, are the crystals of salts really dry? There is a certain water of crystallization that is present in all salts. It is fixed number of water molecules present in one formula unit of salt, such as sodium carbonate with water, copper sulfate with 5 units of water. This water helps in crystallization of molecules. Plaster of Paris uses this water to switch from solid state to a smooth paste. So calcium sulfate with 2 units of water, which is called gypsum, is heated to give rise to plaster of Paris, which is called calcium sulfate hemihydrate, and the remaining water is evaporated. This plaster of Paris is applied by doctors for fixing fractures, making toys, constructions to make the surface smooth. Well, this completes the chapter Acids, Bases and Salts, where we saw the chemical properties of acids and bases and the different salts that we use in daily life. Like and subscribe to this channel for more such videos. Comment below if you have any doubts on this chapter, and we will see you in the next class.